CNCers, Scott here again for CNC Labs. We are going to run you through tutorial number 2 for the Vortex, carving, you got focus there? A skull on the Vortex. The 3 things we're going to teach you in this tutorial are the limits of rotary carving, how to import and position your 3D model, and how to use gSender to rotary surface your stock if you do need to. So let's dive in. Before we get too far into this tutorial, I just want to draw your attention to the Vortex resources section on the website. We'll put the link in the description. Johan and Daniel have been wonderful enough to put a really nice written tutorial for the skull project on those resources. If you can't follow along with something I'm doing, or if you just want a little more detail, check out the resources, check the link in the description. When you break it down, rotary carving isn't actually that much different than normal 2D or 3D carving that we're doing. So there's a couple of key different settings that I'm going to show you all about. So we're going to dive over into VCarve and get started. Oh, hold on. OBS needs to record too. That would have been super annoying. Oh, if you haven't checked out the Vortex resources online, be sure to check out the playlist right here. It's over there, actually, right there.
More. Top, left. Yeah, there.
There?
Yeah.
Okay. It's over there, actually, like way over there. It's got everything Vortex in it. So from your unboxing, your initial setup, your screwing to the wasteboard, and everything else that you're looking for. So if you do need some more resources, be sure to check that out. Link will be in the description as well. Here we are in VCarve. We are going to rip right through this. Like I say, there's the written tutorial that can help you out if I happen to skip or miss any steps. We're not going to spend a ton of time on every single detail, but there is some technical things that you need to follow along with. So here we go. First things first, we're going to create a new file. Again, I'm just going to whip through this because I think you guys are probably far enough along. Even if you're just starting out with Vortex, you're going to have an idea of what's going on. We are going to do rotary carving instead of single or double-sided. That is fairly self-explanatory. The length of your material and your diameter is going to be determined by how big your material is. So that's why I have the 1.49 in here. And when we talk about rotary surfacing, that will really dial that in. Your Z0 position, we recommend it being on the cylinder axis. That's the middle of your material, because if you surface to the outside of it and that changes, then you've lost your Z0. Your XY datum, bottom left, is normal. Your orientation is on the X-axis if you set your Vortex up that way. If you have set it up this way on your machine, on your Y-axis, then you can do that. And flip design, just leave it turned on, because if you do mess with those, it will automatically do the design. It'll automatically flip it for you. So that's document setup in a nutshell. Next, we are just going to go to our modeling tab. We are going to import a component like we always do. And as we will provide in the link to all the files, there is a skull file in there. So if you want to roll along with the skull, click on that guy. It's going to bring up the usual 3D import dialog with a couple of key changes. And this brings up the first limit of rotary carving that we alluded to in the opening. And that is things called overhangs. So it's going to be a little bit tricky to see. There's a little tiny bit underneath the skull, the chin of the skull there, that can't get carved out. And that is like an overhang. So the rotary axis can't get down and underneath that area. So it will only be able to carve straight down. Limit number 1. The easiest way to fix this or to get around it is to just rotate our skull so that it's going to have the best orientation possible for the best carving. So if this was our rotary and it's carving this way, you can see that the skull has been rotated a little bit. If this came in as it was actually imported, the skull would be like this, and it would be the axis on X would be going right into the forehead or the nose area, and you'd lose all those important details. So the way we're going to get around that, because I don't really care about this side of the chin or the back side of the jaw, is to just rotate that into a position that basically keeps the good details and hides the ugly ones. We have a full 3D model. Our orientation is still top. We're going to turn our interactive rotation to the Z axis. And you can see that on our screen here, that's what I was just talking about. The X axis will be going through the nose as it is of the skull and out the back, which the back's fine, but the front you're gonna lose that detail, or you'd have to, monkey with it after. By changing the interactive rotation to Z, I can now literally just click on the model and rotate it up, and it will lag a little bit, but you can see that it's starting to, look at that! First time I got it. So that red axis there is showing what your X is going to look like. And it is right basically in the same spot as this one is. It's going to go underneath the jaw. We're not going to lose any important details. And we're going to have all the stuff that we do care about front and center. Done. Wow, that was easy. That never happens. My model units are whatever you're comfortable with. The model diameter is obviously incorrect. So we're going to scale our model to fit material. Ta-da! And you can see that there's my material length of 5 1/8, this guy, and 1.5 inches round ballpark. And that is all we needed to do to import and position the 3D model to optimize it for the best carving possible. We have our model positioned. We're going to hit OK, click, and you'll see that it now imports into, well, I guess we can go to 2D space. This is going to look a little bit, not new, but if you did project number 1, you'll already understand that this is basically our cylinder stretched out and unwrapped. It looks a little funky, but you can start to see the bottom of the jaw here. There's the eyes, forehead, and things of that nature. So the second limitation of rotary carving is that it can't go past the center point of your model. So on this, the cylinder, it can't go past center because it's going to chop stuff off and it's not going to work. So that's just limitation number 2 to be aware of when you're carving all these things and rotating and having your position in place. So we're actually going, damn it! We're actually going to add 3 different tabs to this particular cylinder. I wish I had a working example sitting there, but you can see here's cylinder number 1, tab number 1. We're gonna have tab number 2 way up here, and then we've got a third one up the middle there, and that's just so that we can have the skullsy looking, up and elevated a little bit. You don't need this third one. You could just have the model joined right to your bottom tab, but then it's a different dynamic. So depending on your model, for our particular case, we're gonna add 3, and we're gonna do that right now. So you are going to go to your clip art tab, your 3D tabs, and you're just gonna grab any old rectangle that you want because it doesn't matter. We're gonna, mess with the size. You can double click or you can drag and drop. So for the top tab, very simply, we are just going to position it way up there. And then if you hold Alt, you'll be able to distort this however you like. So for me, I'm going to stretch it out to there. And then I'm just going to hold Alt and Control and drag one down to the bottom. 2 out of 3 tabs, done, easy peasy. This third one's a little bit tricky because it kind of starts to mess with your workspace, but you'll understand it once we go through it. So you can Alt and Control drag again. You have another 3D tab, but this one we're going to cover the entire document work size with. It's going to block all your stuff and you won't be able to see, but you'll understand in just a second why we're doing it. And tip number 1, because I forgot about this, if you go over to your modeling tab and your deselected tabs that we've already created, they're in the way, you can just check them off and then you can see your whole workspace. So now we're going to take that third tab, hold Alt so we can distort it, and we are going to drag it across the entire work surface. Something like that. Now you're saying, Scott, now I'm looking at a gray box instead of my model, and I'm saying, yes, you are. So all you have to do is double click on that new tab, go to your 3D view, change your view because you can't see what's going on, and you can see that that tab is the size of your stock. Well, that's not helpful because it's burying your model in it. But if you just change your shape height, which is right here, and you can use that with arrows or with your mouse, you'll start to see that your model, come on, show yourself. Aha! You can start to see that your model pops out. So you put that basically as thick as you want so that it's not distorting anything. It's not in the way. And right about there is pretty good. It's still going to get a little bit of that jawline. So I'm going to leave it there because quite honestly, I'm not that worried about it. I know I can sand it out if I want to. If you're not happy with your model position at this point, if you do want it more rotated, or if you do want to change it, you can always go back to, your modeling tab. You can right click on your skull and you can re-import it and change the orientation of it, just like you did when you did it the first time. Nothing gets lost, you're just changing it. So let's actually do that because I don't like the way that looks. So it goes back to re-import. We change the interactive to Z again. And I'm going to zoom in just a little bit because I don't want it to be quite. So again, this is where those overhangs are going to be a factor. If you go to a side view, which would be there will be a line that comes straight down off of the bottom of that jaw. I'm okay with it. Scale is incorrect. So we'll hit scale to fit model material again. And if I'm being honest, I'm going to make that a little bit smaller. I didn't do that the first time, but I'm gonna make it just a little tiny bit smaller, just so that it doesn't catch the edge of the material. I probably should have said that the first time. sorry. Here we are, back in our 3D space, and you can see there's that overhang that I was just talking about. You're gonna get a little bit of this because the bit can't carve down through there, but I'm okay with how that looks. It's not gonna hurt the aesthetic. That's it for 3D tabs. Now that we have our 3D tabs in here, our model's positioned the way we like it, you can go and change the height of those 3D tabs if you want to, but the way I'm going to set up the model with the toolpaths, we're not even going to actually carve those out. So they're there and they will be left in place when it's carving, which is fantastic because it doesn't waste time carving. And we're gonna talk about toolpaths right now. So this is actually a really good segue. So fire up our tab, we'll pin it in place. We are going to use a 1/4 inch upcut to do the rotary surfacing as well as the rough pass on the skull. And then we're going to use a 1/4 inch tapered ball nose to do the fine details. If you're not familiar with roughing and finishing passes, the roughing pass will just use a bigger bit. It'll remove more material faster so you can get the final pass done sooner and easier. It basically saves wear and tear in your bits and it saves time overall. Here we are. We got our 2D view up and I'm going to select my skull from my components list so that I don't have one of the tabs selected. We're going to do my circular pyramid for the roughing pass. I already have my 2 flute upcut end mill in there. I will show you my settings. Here they are. The only thing that I really tweaked was my feed and my plunge rate. Everything else I left as is, and it chewed through this like fairly quickly. So we'll leave those as is. I'm good with that. Boom. Boundary offset, make sure that's set to 0 because that can mess with your stuff. And this is where I said earlier, I'm not going to worry about carving out my tabs because I'm going to use the wonderful selected vector. So I'm just going to draw a simple rectangle, just around the shape of the skull. Get over there. Just past, just past, just past. So the reason I'm doing this is, like I said, while this is doing its carving, instead of carving these out and messing with this and wasting my time, I'm basically going to tell it, nope, only carve what's in between here and here. It's going to save time and it doesn't change the final outcome, so I'm all about saving time. You have your model selected. You are going to hit selected vector. You are going to change your roughing strategy to 3D raster and change your raster angle to either 90 or 270. And that just makes sure that it's carving properly and making everything look smooth and fancy. I'm going to change the name to skull roughing, and then I'm going to hit calculate. And then we can preview our selected toolpath and you will see that we are starting to see the rough formation of our skull. Yay. There it is. So you can see it doesn't touch the tabs. It only hits that stuff in between that selected vector. It saves time. That's marvelous. We'll go back to our 2D view. We'll keep everything selected the way it is, and we will go and make a 3D finishing toolpath. We use the 1/4 inch tapered ball nose, just like I said. I'll show you my settings there too. And again, the feed and the speed rate, this is different calculation methods than it is for normal carving. So we're recommending just leaving these settings as they are. And I've literally carved 2 or 3 of these out now. They work just fine and dandy on hardwood or softwood. So if you want to mess with them, go ahead. But what we have in here will work just fine. So we're going to say okay, and we're still going to use our selected vector. Our boundary offset is still going to be 0. Our raster is at 90, and we are going to call this skull finish. And we are going to hit calculate. And this one's going to take a little tiny bit longer. And then we will preview that selected toolpath and you'll see it scribbling along and doing its thing. Ta-da! Finishing toolpath. Now, because there's a little more information here, you'll see that maybe it takes a second longer to generate that preview. Overall, not a big deal. Now, I'm already seeing an issue though, where my tab is, I'm gonna have to fix that because that looks far too skinny to me and I think that that's going to break. Maybe it's not. Actually, I have a file open already, so I'm just gonna check that one because why not? So I'm gonna preview these two and I'm gonna see what happens. Just to double check because I've already done this project and I wanna make sure that I'm giving you guys good information. Huh? That's not what it's supposed to look like. Alrighty, so the reason my preview is messed up, and this is 100% user error, was I had all of my tabs turned off. It's gonna make a difference. I'm going to recalculate just to make sure everybody's happy. Nothing else is going to change. However, my tabs are going to do what they're supposed to do. So here we go, and I just realized that I spelled finishing wrong. Finish Whew. Oh, because I had just finished. There we go. Well, it's spelled right now. Whew. These short tutorials are killing me. And now we are going to preview. You know what? I'll just do the roughing one so you can see what's going on. Preview the selected one. Again, tabs at the top and the bottom are going to be great. There we go. That looks basically the same, but the finish pass is now going to look much better than it did. It's going to look the same, but that little spindle at the top will not be C. Aha! It's not so skinny. It's going to be chunky, and it's going to hold it on there. It's going to hold it on here, and that's it for your creation of toolpaths. We're happy with our toolpaths. Our settings are dialed in. This is hopefully easy to follow along with. There's not really a lot of crazy settings going on. So we're just going to go over and we are going to save our toolpaths. If you have not downloaded the Vortex post-processor, we'll put a link in the description. Make sure you get that because otherwise you literally can't use this thing. That's the only difference between a normal carving job and the rotary is that your post-processor will be, instead of gerbil, whichever one you like, it's going to be Vortex Axis right there. Click on it. Same thing, visible toolpaths to one file. Johan does talk about tool changes in his written tutorial. I'm not going to go there. I'm keeping it simple. So I'm literally going to select my roughing pass. I'm going to save it to my gcode folder, and they're already in there. And Louis is going to yell at me that I don't actually hit save. So I'm going to make a new folder. I'm going to call it X. And I'm going to save my skull roughing in there. And I'm going to deselect and save my skull finish in the same folder. So you actually see me click save because we don't want people thinking that we're not actually clicking the button. We're going to hit close. We're going to save our file because nobody likes losing their file. It's going to go up here and I will call this skull tutorial. And I spelled it right. Hit enter. vCarve is done. It's that easy. We are going to start loading our files in gSender and doing that in just a quick second, but before we do that, we have to turn this rectangle into a cylinder. So the easy peasy way of doing that is to find the corners of your piece, draw a line from the corner, draw a line from corner to opposite corner again. There we go. You have your center point now, right about there. Because this piece of material is obviously too big to fit in this chuck set of jaws or the other one, we're going to use this handy dandy little plate attachment. The easiest way to do this, and again, you don't need to do this, is you can just drop a screw through the middle, line it up to the middle of your X, and that tells you where the center of this needs to be. I'm not gonna lie, I don't do that very often. I eyeball it because this thing is gonna turn that into what we need it to be. Drop in a couple of screws. If you see it come off center, then just kind of get it close enough. There we go. Yeah, that can go away. This can come out. And now we're just going to lock this into the jaws on our Vortex. So you make sure that your screws that you've just put in are not in line, right? You don't want them to be in line like that. You're gonna slide them over, grab your chuck, and give a little crank, and ta-da! You've got your jaws locked in, tightened down. We're gonna slide our tailstock over. Once it's touching the piece of wood over here, you can lock your lever down on this side. Give it a couple of cranks, maybe a couple more so I don't show that I gouged the metal last week when I made a mistake. Hand tighten, and we're good to go. Before we get into actually carving this and doing the rotary surfacing, you can see right now my A axis has the ability to rotate freely. That is not necessarily an issue, but because we're going to be doing a bit change, if for some reason your chuck turns while you're doing your bit change, you've basically lost your ability to really, well, yes, you can reset your zero on this. I'm going to give you a tip about, it's called turning on the holding current. We're going to connect to our machine, and we are using gSender Edge here. Remember that when you're using the rotary, you need to be using Edge. So I'm just going to unlock my machine because nothing's going on. I don't need to worry about homing right now. You go to your firmware and you would change this number 1, it's usually a $, the step idle delay. That's defaulted at 100. You turn that to 255, and that is going to stop the A axis from being able to turn freely. You can see. So it's called turning on your holding current. Super handy feature because now when you do your tool change, if something does happen, you can't move this and it stays in place. The only thing to know about is when you're switching between your Y and your A, you need to power down your machine if you have this option turned on. So just notice that, pay attention for that. It is in the other tutorial videos too, in those resources. So there we go, tip number 1. We're going to go over here to the Rotary tab, and we are going to go to Rotary Surfacing right there. And it's going to bring up this wonderful little prompt. Now, yes, we are going to have to put our bit in at some point and do a 0. The order doesn't matter. You're gonna have to do both, so it's up to you what you wanna do. Again, another little tip or hint, my material is 5 1/8 long. The issue with that, if I tell it 5 1/8, is it's gonna carve right from that leftmost edge, and there's screws going through. I don't wanna hit the plate that's holding it in, so I'm purposely going to offset by a dimension. That dimension's up to you and your piece and what you're comfortable with. I was smart enough, I said, you know what? If I go 4.5 inches over from this edge back to here, then it will start carving there. Yes, it's gonna leave a little chunk, but that's kind of safety, and I'm okay with that. So I'm telling it 4.5. I'm telling it that my start dimension is 2.5. My finished dimension I want to be 1.49 because I want it to be just a little bit under my smallest dimension, which is 1.5. Step down doesn't really matter. You can leave the defaults, quite honestly, is basically what I'm saying with that. Put in your bit diameter, whichever you're using. Your step over is just like a normal carve where you are moving over in between passes. 15% is fantastic. You're going to hit generate gcode right there. You'll see it generate it. You'll hit run on main visualizer, and you'll see that there's your gcode. And now we just have to zero out our bit. For this surfacing, we are using that 1/4 inch 2-flute upcut bit. Make sure you raise your Z axis basically as high as it will go. Nothing out of the ordinary there. Slide your bit in, push your red button, turn it to hand tighten, use your wrenches, and you are tight. Now we have to zero this. We've already zeroed our Y because we did that when we set up our vortex. Our X is easy enough just to move it to where we want it to be. And then we are going to plug in our banana connector there. We're going to put on our magnet, and we are going to probe rotary Z axis. That's what we're doing this time. I forgot. Now we're going to probe our Z height of our bit against our chuck. Huge word of warning, caution, because I literally just did this. Unlike your auto zero touch plate, when you hit the probe rotary Z axis on this, it's not going to dummy check it. It's not going to ask you for continuity. It will just start moving. So I literally hit it and it started moving and I had to stop. So we're going to move over on our X axis. Till your bit is hovering just over top of your chuck. Make sure that your magnet is solid, your banana connector's in, make sure your wires are all tight, and then you are going to hit that probe rotary Z axis over there, and it's automatically going to test it out for you. Wonderful. That easy, that simple. Disconnect, disconnect, hang it where you like to. Y is good, Z's good. All we have to do is tell it where A is going to be, so this is about as simple as it gets. Move it back over. Another just, again, word of caution. Because you've dropped some screws in here, don't put it right on the edge of your wood, and if you are going to, you might run into the screws. I move mine over purposely, but I also I calculate that offset with my file size in vCarve so that I don't have to worry about running over and hitting my chuck stop back here, which I already did last week, and that error's right back there. It's hidden so no one sees it. So we're gonna zero our X, and now we can basically hit start job, and this thing's gonna start spinning. It'll go slow at first just to get it eased in, and then it will go to town and carve this whole thing out, and it'll be wonderful, and we'll have a cylinder when we're done. Roughing pass is done. Didn't take very long at all. We are going to change over to our tapered ball nose for our finishing pass. Sometimes these bits are a little bit long, so you may have to find that you have to move it over on your X axis in order to slide it into the collet. So I'm gonna move it over on X. There's a little gap right here in the model, so that should bode well for being able to get it out. Oh yeah. Should do it. There we go. And because, again, this tapered ball nose is a little bit longer, but by moving it over just a little bit on your X, you're not losing your 0 on X, which is the easy part of it. It's just moving it over. And apparently, this bit is not being cooperative. Wow. Well, let's see if there's something in there. Oh, there was dust in there. Sneaky, sneaky. There we go. Now it should cooperate like that. Slide it up about as much as you can because there's not a lot of room on my specific machine. Tighten it down. We're gonna move it back over on X.
I'm not using the tools.
Thank you to my videographer for reminding me that you need to use the wrenches because, you know, I've only carved like a million things and still managed to forget. Remembering to bring your bit over your chuck, making sure that you have your banana connector, your magnet on, and as soon as you hit probe rotary Z right down here, it's going to start probing. So make sure you're ready for it and it's in the right position. It is. We're gonna check it. Bing, bong. And our Z is done. It was that simple for that bit change. That's like the easiest thing ever. I'm going to click on Go to X. That's the same place it was before. I'm going to load my file, which is my finish pass. There it is. This is ready to go. It's that simple, guys. It seems daunting because you got all kinds of things going on and there are some technical things you do need to know about. There's some different settings, some different things that you need to change around, some orders of operation, but we're gonna hit start on this thing and that skull is gonna turn into this skull in about 15 minutes. It's a very small spindle in the middle. Here's Scully Jr., and you may or may not be able to tell, but right here on the skull and right here on the skull, I didn't quite scale my model down quite enough, and it's still kind of like the outside of the cylinder that we rough carved. Scully Sr. here, however, has a very nice cranial outline and is much better. So just a word to the wise, check your previews, make sure your sizes are, your dimensions are proper, because that's a learning from me kind of thing. So learn from me. I gotta not say so. I'm looking at that and it says so. All right. So, damn it! A couple of new things to remember, a couple of different settings to tweak, but overall rotary carving isn't all that different from, good old flat old school carving. So hopefully this tutorial plus the written one took some of the uncertainty out of, rotary carving if you weren't sure, and now you're happy to get out there and start turning your own projects. Turning. Get it? Wah, wah. Till the next one, we'll see you around the Sienci. We're done.
Thank you.
Importing. Okay. Import limits.
Importing.
I just refuse to remember this. Limits, importing, surfacing. Import. My brain just I already said before, so I gotta come with another word and I gotta stop saying so too. All right.
Oh, sorry.
I'll do it again.
It's my fault.
It is your fault. I'm glad you admit that. I have it on film now too. I almost said so. Damn it. I'm glad you have to edit this stuff, not me anymore. You see similarity? No, it'd be more like this one. Well, maybe not that one. Alrighty, so Do you know Matthew McConaughey apparently was going bald and found some secret shampoo that worked for him? Well, the good news is I know you're not going to put that on the internet. Oh, man.